Okay, so we move on. So now we begin the session on agency highlights. And the first one is from Helen Beggs online from the Bureau of Meteorology.
Right, thank you very much. I'll just share my screen. Right, thank you. Right, today I'm so happy to be able to report on the contributions to GRIST from the Bureau of Meteorology, IMOS project and CSIRO. Shown here is the Bureau's SST team of Huang, Chris, me, Pallavi and Kat. The Bureau of Meteorology through IMOS project produces a wide range of high-resolution, GRIST-compliant level 2, 3 and 4 products from AVHR, VIIRS and HIMARI sensors over the Australian region dating back to 1992. And Australian agencies and IMOS also contribute in situ SST observations from ships, Argo floats, drifting buoys, and a Southern Ocean flux mooring. Recently, Zhang used the Southern Ocean mooring SST data to validate IMOS multi-sensor L3S and geopolar multi-sensor L3S composites, and he will speak about this on Wednesday. You can see examples of these products in the bottom two figures here, where on the left, a multi-sensor L3S is derived from VIIRS and AVHR data, and on the right, geopolar multi-sensor L3S has greater spatial coverage from the addition of HIMARI data. The data sets shown here are available in the GRIST catalogue, as well as from the NCEI thread server and AODN portals. This year, Pallavi and Kat, with help from Owen Embry and John Mataz, have reprocessed HIMARI 9 L2P products using the latest CCI version 3 Bayesian cloud detection and radiative transfer model RTTOV 13.2 code from University of Reading and an updated Bureau SSES bias model. These will be used to produce 2-kilometre resolution L3C and L3S products like the ones shown here for HIMARI 8. For details, please see Pallavi's poster and her pre-recorded presentation online. The Bureau's daily foundation SST analyses, RAMSA on the top left there and GAMSA on the top right, ingest satellite data from AVHR, VIIRS and AMSA2 sensors and in situ data from ships, drifting buoys and moorings. The plot on the bottom of a robust standard deviation of L4 minus GAMSA obtained from the NOAA SQUAM website indicates that from April 2020, when GAMSA started to ingest the Expo VIIRS some L3 USST from NOAA, GAMSA has agreed closely with CMC, which is shown here in red, NOAA's Geopolar Blend in purple, and Ostia in orange. Like SST analyses, which ingest the same VIIRS data sets. This month, the Bureau aims to replace a legacy weekly and monthly 1 degree SST analyses, which were developed in 1994 by your old friend Neville Smith, with GAMSA daily 1/4 degree SST analyses to derive all weekly and monthly climate products. And for SST anomaly maps, the Bureau will replace a Reynolds and Smith 1961 to 1990 climatology with a new CCI version 3, 1991 to 2020 climatology. This will significantly impact the Bureau's climate products with warmer anomalies over some parts of the ocean and cooler over other regions. The goal of the IMOS SHIP SST Census project is to improve quantity, quality and timeliness of SHIP SST data in the Australian region. From 2008 through IMOS, 25 ships have reported QC'd a real-time SST depth to the GTS, IQAM and AODN, are using Seabird SB38 or SB48 SST calibrated sensors. You can see in the top map their cruise tracks over the past 16 years. Currently, 8 ships report a real-time QC data, as can be seen in the plot from NOAA's IQAM website of robust standard deviation of in situ SST minus Canada's CNC SST analysis. IMOS has contributed ship SST depth data at greater accuracy than most other ship observations on the GTS. The IMOS ship SST data are ingested into climate databases and operational SST analyses and are available from IQAM for satellite SST validation and from the AODN portal. In 2014, an ISAR 5D radiometer was installed on RV Investigator, along with an SBE38, a water intake temperature sensor. Reprocessed ISAR skin SST data to July 2021 are available from SHIPS for SST portal and the AODN and have been used to validate infrared satellite skin SST data as well as ocean cool skin models. The ISAR 5D failed in late April 2023, and since then only the ISAR 5E has been deployed, but this has proven unfortunately less reliable than the ISAR 5D and is shortly going to be returned to University of Southampton for repair. CSIRO has ordered another ISAR 5E instrument, which should arrive next month, we hope. Over the coming year, we'll produce real-time IMOS HEMERI 9, L2P, L3C, and geopolar multi-sensor L3S SST products and reprocess these back to October 22. We'll investigate generating a real-time 2-kilometre resolution thermal stress and also marine some heat wave metrics from the geopolar multi-sensor L3S products like the ones shown here. Please see Pallavi's poster for more information. The Bureau will provide a real-time SST, meteorological data from 3 new vessels, and CSIRO will reprocess the ISAR data back to 2021. I'll be taking extended leave from 26th of July prior to retiring next year. So in future, Pallavi and Haiphong will be your contacts for the Bureau Zymos satellite and ship SST data streams. However, I would really like to stay involved with GRIS science after my retirement. I would like to say a huge thank you to the GRIS science team and project office for a wonderful 20 years of friendship and collaboration. I hope we can stay in touch, and thank you very much.
Thank you very much, Helen, and thank you to you for all of your activities in GRIST over the last 20 years, and you will definitely be missed, and we hope to see you in Copenhagen next year.
I hope so too.
Yeah.
Thank you.
Any questions for Helen? I don't think there's any online. So thanks again, Helen. And we move on now to the next presenter, which is Stephane Picart from Meteo France.
Not working? Is it? Okay, cool. Good morning, everyone. So I'm here to present a small progress report on the activity from the OSISAF. The OSISAF is a consortium. It's actually part of the ground segment of EUMETSAT. It's composed of Meteo France as a leading institute, and Meteorological Institute from the Netherlands, Norway, and Denmark, and also ISMAR. OSISAF is providing data of the ocean surface made of a number of satellites. Essentially, it's a meteorological satellite from EUMETSAT, European Meteorological Satellite, and also American NOAA 20 and GOES 16 in particular. So OSISAF is delivering many products, including sea surface temperature, of course, ice surface temperature, wind product, many parameters, wind emissivity, drift, and so on. And also radiative fluxes. So I'm not going to go through all the products we made. For that, there is a table in the proceeding of the conference, and you can have a look. There is a up-to-date list of the products we deliver. One thing I just want to mention is that OSISAF is mainly doing operational products, so near real-time distribution of data, but also some reprocessing activity, and has made a number of CDR in the past, and is still doing some. So first of all, I'm going to talk a little bit about what has been done recently for the global GEO satellite and the LEO satellite at global scale. So we have a number of satellites processed. The list is here, Meteosat, GOES, and so on. A number of products from L2P to L3C. All these products are operational, so delivered in near real time. So MTG was launched in end of 2022, and MTG carries the instrument FCI, which is the new generation of geostationary instrument from Europe. So to date, we don't have any continuous flow of data. We had some sample, but no continuous flow. We are, however, ready to process, and as soon as we get data, we can provide operational products. However, the instrument has some little problem, and we may have to wait a little while before we get some data. We are preparing for METOP SG, so METOP second generation, which is the new generation of low Earth orbiter from EUMETSAT. The launch is planned in 26, but we still have to add some to undergo some technical tests, and everything is ready and ready to go when we receive some data. We are preparing a new reprocessing of the MSG archive from 2004 to 2024. At the moment, we are considering using the bias-aware optimal estimation, but we are just at the beginning right now of this processing. We've done one in the past, and the illustration here show you one of the results we got from the past reprocessing from 2004 to 2012. We have made some tests to use CAMS data in our processing chain, so to process the dust aerosol, at least to flag the dust aerosol problems. This is ongoing, but I think next year will be it will be in the operational processing chain of the low Earth orbiter sensor, and then after that will be put in the geo sensor processing chain. And we are currently working on improving the climatology. We've been using old climatology so far, so we are now using up-to-date climatology in our processing chain. This is ongoing. For high latitude sea surface temperature and ice surface temperature, so there is a number of products, L2 and L3. They are combined SST and IST products, as illustrated here. In the next year or so, Steinar here can confirm, I think in the next year or so, there will be a new Bayesian cloud mask added to the processing. So it will be provided as well as a variable. So the colleague from Norway and Denmark also working on a reprocessing activity, and currently have an IST and SST product, climate data record. They are working to extend this climate data record, and this should be ready next year. So final slide to give you a few longer-term activity that we are working on. One of them is to harmonize products across EUMETSAT products, so making it consistent with what is provided today for Sentinel-3 SST product. And that, for example, includes adding a cool skin model and a diurnal variability model to provide skin surface temperature, as opposed to sub-skin temperature that like we do today. And we are working, OSISAF is also working in making a comprehensive in situ data set that will be quality control. This is an activity led by IFREMER and is ongoing and should be ready in a couple of years. And next year we will start planning for the next phase of the OSISAF project. And this is a call for you. If you have needs and wishes, you can talk to us. We are several here from the OSISAF project, and we could consider including that to the next proposal. That's all. Just to finish, I just put a couple of links here on the EUMETSAT risk catalog and the OSISAF website. Thank you very much.
Thank you, Stephane. Any questions? Just checking online. No, I don't think we've got any. Okay, thanks again. So the next presentation we have today is Sheekela Baker-Yeboah from NOAA NESDIS.
Do I advance it or, yeah, this is the, yep. Okay. I think I can get this working. Hello, everyone. I'm Sheekela. I'm going to talk to you about the agency report for the NOAA NESDIS SSTs. And we have multiple teams that work on our SSTs. We're working on getting our information together currently as we continue to present here. Oh, it went backwards. That's what I figured. Okay, great. There we go. Now it's going too fast. Okay, all right. So NESDIS, this is the other side. Essentially, NOAA provides a variety of SSTs. Most of them come out of the Office of NESDIS, the National Environmental Satellite Data Services Group. We work also with our line offices, AOI, Office of Atmospheric and Ocean Research as well. And then our fisheries office pretty much uses the SST. So most of the SSTs in NOAA come out of our NESDIS office, essentially. Okay. And that's, as I presented last time, we were moving all of our products into a cloud environment. And so we are still working on that. It has been a huge undertaking. Things are not where we thought they would be at this point. But we do have quite a few projects that we've merged over onto that system, our NESDIS Common Cloud Framework within NOAA. And it is an ongoing process as we try to make all of that information available to users. Here. Okay, all right, so this is not the one that got updated. Sorry about that. Okay, so we have out of our NESDIS office, we have STAR, our Satellite Applications Group, is where we get a lot of our algorithms updated, generated, products, processing, working. Our blended SST is one of our primary ones that we have with Andy Harris. And Eileen, as you know, she retired in December just last year. So acting in her post is Veronica is helping to help move things along with that. Veronica Lance is here with us. So the blended SST products have been delayed for moving into the cloud. In fact, we're looking to getting those in it was September of last year, and now it's going to be September of this year. There were some updates to the slides that are not provided here. Sorry about that. And in addition to that, we have our Coral Reef Watch products associated with that product. Essentially, we have a lot of users for our blended SST. In fact, we're seeing that our level 4 analyses are the ones that are pulling in most of our users. So in addition to our level 2s and our level 3s, our level 4 analyses are the ones that most of our users are using. That's with the NCEI OISST as well. So most of our users are pulling those data predominantly. And then we have our specialized users for our level 2s and level 3 products as well. We are still working on our comparison paper for the coral reef using SSTs with William and Prosenjit, and we are hoping to keep that going as we look at revising SSTs to improve estimates that are used particularly for looking at corals, which is a hot topic, as you know, of this year. So it's very important. Again, looking at those level 4 gap-free analysis are very, very important to improve for SST community. Going here. Here we go. Oh, went really fast. I think I missed one. Okay. All right. So the day and night analyses, I think the most updates we have is with that one is Eddie's going to be giving a talk on dynamical modeling improvements, and his postdoc is also going to be giving a talk on what things that are going on with the bias correction and all. So that look forward to that one. The Expo SSTs, I think the latest one is the NOAA 21 that we've got migrated into the cloud. We did not get the METEOSAT third generations as quickly as we had hoped to get them. So that is still a process in work. We're trying to get that data flowing consistently so that the Expo products can actually be used to generate those as well. We still have our second generation physical retrieval products out of NOAA that we're using into our upper level product suite that we provide. So we don't have as many with the physical retrieval as we had before, but we do still have our METEOSAT third generation SSTs being produced. The GOES products, we're looking at getting those migrated into the NCCF as well this year. That's been delayed as well. It's going to be December 2024. Again, as we look at moving things into the cloud, we're looking forward to seeing the processing work more smoothly so that we can do more analysis, more reprocessing, and more consistently. However, it's a huge undertaking, and we are still trying to get those GOES ones into that system as well. I think those are all of the Expo updates I have there. Okay. And then we have our AMSR SSTs. We are looking forward to getting those on board. Actually, we've in October 24, we're expected to get the AMSR 2s in the system, and then the AMSR 3s. Paul Chang's the group is working on getting those. We'll be working on getting those processed as well. That's sort of something that we're looking forward to in the future. The LTSRF is still going, and we're trying to get that system online in the cloud as well. Huai-min and NCEIers will be giving a talk on processes for the LTSRF. We are looking to have that migrated. I think they're starting to work on that this year. Hopefully, as you know, we host all of our GRIST SSTs in that system. The ones that are recently migrated in the cloud are also in the NOAA archive system. That's our primary system that we're working to make sure all of our NOAA SSTs are flowing through that system. But I think since the last year, the data volumes are continuing to increase. In 2024 here, Huai-min reports that we've added for the archive system, the NOAA 21s, level 2s, level 3 Us, and the level 3 S supercollated products are there as well. And again, we're looking at making sure we get those migrated into the cloud as well, the L3S. They're not quite into the cloud system yet. So in addition to that, we have ongoing collaborations with the Andy and Gary doing various work with the bias corrections that are taking place. I think the latest update, Andy has been doing a lot of work on that, and he is going to give a short talk. I think he started looking at some of the NOAA 20 versus the METEOSAT C, METOP C differences in terms of the bias correction. He was looking at the area where there was a lot of aerosol wind desert particles off of Africa there. And it's an ongoing work in progress. You will see a couple of talks again with Andy Harris, and his postdoc will be presented in the sessions this week. Prosenjit has been working also using the CCI data and looking at decadal trends to sort of see if he could pull some things together. He's also got a viewer that helps to give a quick view of the various SST products. So there's a lot of things going on in NOAA these days, and we're hoping to look at improving SSTs as we look at also sort of futuristic approach of pulling things together from a level 2, level 3 to level 4 processes. And we're actually working on getting the products. I think we're looking at a new gen SST. This one here, we're hoping to get the lake water and Arctic SSTs moving. This is something that we had hoped to be working on this year. I think Andy has done some preliminary checks, but we just haven't had enough funding to get the work going, but we're still planning to move that work forward. We've had a lot of requests for Arctic SSTs. As you know, the Arctic also is a hot topic in addition to coral reefs. SSTs are very important around the world. And again, we have a lot of users who are reaching out and wanting to have sort of a level 4 type analysis in addition to our lower level products. So we're looking forward to getting our Arctic and lake water SSTs funded moving forward. We're still working on that. And again, Andy is heading that up. We did find that the physical retrieval was performing best on that. So we've been, again, collaboratively looking at comparing what we see with the different algorithms for coral reefs, and we'll be looking forward to doing that as well. I think Andy has done some preliminary work for the lakes as well as the Arctic there. And again, there are pieces in place. We just need to get the funding. Okay, so Expo 3.0, we were looking to have a single version 3.0 with both the LEO and GEOs. Again, another item that we're hoping to eventually move forward in the future. We had delays with our third generation sea surface temperature products because we didn't get the data flowing as we had expected. And then we've just had a lot of changes going on. So at this stage, when we get the 3.0, we're looking to sort of make our products more consistent as we look at the different versions. So look at getting a 3.0 with the GOES included and the SMPP NOAA 20 and NOAA 21, in addition to the L3S products will be included in that one. So that is indeed also a continuous work in progress. OISSTs and Pathfinder SSTs, DORA is planning to produce, again, the sort of a new generation products. As we think about OISST, it's been around a very long time. We've had a lot of users for our OISST. It's an upper level analysis as well. And we're looking at updating that as we move forward with NCEI. Huai-min and his team have been working to try to improve that. And again, we're all looking to get more SST funding to do additional work for those products, and sort of maintaining those climate data sort of statistics that go into that long-term series analyses. Again, we are really looking forward to moving things forward on that with a new generation type of SST. We're not quite sure if that's fully funded, but we have components of that that are funded as we continue to move forward. And this is what I was just mentioning, looking at the SST analysis as we look at the requirements for our next generation SSTs. It's something that we're working on, and Veronica has been helping to move that forward with us. And again, it's a product that we're looking to sort of look at our SSTs as a whole and see how we can consistently move things together for our L2s and our L3s, as well as our L4s in the future. We are still using the format. The GRIS format is very, very important. NOAA has been using it for decades, and we're still pushing to keep that format as we move into the cloud. We're looking at sort of data provenance and trying to follow all the processing. And so sometimes there's a tendency to have file name changes. And we are really pushing to keep our GRIS requirements in place, particularly for our SSTs, and maybe end up using some of that for other products as well. So there's a lot of history in keeping that GDS format going. So near the end here, basically for our cloud movement, we're looking at STAR, DOSPO, and NCEI, including the archive service. It will be migrated to the NCCF over the next 5 years. It's a huge undertaking. We are having a lot of pains, but we are still working on it and trying to make it happen. Ken is here. He's helping to head up the archive component of that and moving the archive into the cloud. Again, that would help us get all of our LTSR components into the cloud, and that is a process that's been started. So as reported last year, the first cloud archive workflows will go into operations in late 2024, and the planning for migration of the parts of NCEI on-prem archive that hold the GRIS LTSR data begins in July and will be concluded in September, hopefully, if all goes well. Those exciting dates. Thank you. I'll take any questions.
Thank you, Sheekela. Any questions? Helen, I think you've got your hand up. So there's one online. Yeah.
Yes, thank you. Hi, Sheekela. Great to see you and hear from you.
Helen, you can ask you a question.
I was wondering, I may have missed it, but when do you expect the PDA data that we currently get at the Bureau to go on the cloud? Like, when do we have to switch over, and will NPP VIA's data, will that leave the PDA soon? Because we were just wondering what we need to plan for. Thank you.
Yes, Helen. Okay, regarding the PDA data distribution, yes, that is something that we're looking at for early 2025. We've just started the planning phase of that, in fact, this month. And so we are starting to undertake that work this quarter and into next quarter. So we're thinking that we're hoping that we'll have that done in early 2025. Thank you for the question.
Thank you.
Okay, thank you. So we move on. So the next presentation is Boyin Huang giving the NOAA NCEI report.
Actually, can you hear me? Yes, can you hear me? This Huai-min Zhang, track present online.
Yes, we can hear you.
Okay, good. Can you see my screen now?
Not yet.
Yeah. Okay, maybe it's slow. Okay, can you see my screen now? See, let's go to the meeting side.
I think we are seeing your screen already.
You see my screen? Okay, good. Okay. So do you see?
Can you go to the present? No, not the presentation. We see your screen, not the presentation. We see your desktop with the MS Teams.
Let me see. I shared the whole entire screen.
Yes. Yeah, looks good.
Looks good now. Okay, thank you. Okay,
can you go into slideshow, please?
Yeah. Okay.
Okay.
It's a little delay actually. Yeah. Well, yeah. Thank you, everyone. Sorry, I couldn't be there this trip, but fortunately, we have two people over there from NCEI, Dr. Boyin Huang and Dr. Garrett Graham over there. And if you have questions about NCEI's activities, you can talk to them during the meeting. Basically, this is an overview of ocean surface section product portfolio, particularly for some SST and also seas reservoirs as well. Basically, we collect the data from, for surface marine and meteorology data as well from both in situ and satellite observations. And from there, we generate the high-level products as well. So then, we formulate the data collection like the foundational data sets like IQS, and to the high level are graded and blended products like ERSSD, OISSD, blend Stevens, and so on and so forth. So the approach is basically taking the tier process, and we start as collecting data. On the right-hand side, you can see that data from in situ observations, ships, buoys, and also in this case we collect aqua flows SST as well, and then the surface autonomous vehicles like sail drones and so on and so forth. And of course, and we also the satellite data, and then we generate high level. When we combine in situ and satellite data, we have the OISST and the ERSD based, the in situ data only. When you merge with land part, you climate the generate the climate data over the global surface, which has used for NOAA's monthly climate reports. And progress on IQS, again, IQS basically is most people know about this already. It's at least the attention try to be the world's most extensive surface marine and meteorology data collection historically from right now from 1662 and onward. And right now we have two versions. One is the monthly version from 1662 to present, and also we create the daily version. Daily version starting with January 10, 2015. So the activities on the IQS right now, we have daily monitoring of the surface observation system platforms, and we have plots like on the left. Whenever we see something, does not behave as expected, we contact the data collection centers and see what's going on, and sometimes the internet issues, things like that. And then we also merge the buffer traditional tag, GTS data stream, and combine them together into the merge data IQS collections, as shown on the right-hand side here. And then the data IQS has used the input high-level products like OISSD and other user communities. Again, this is the ERSSD, which is the centennial scale, starting from 1854 to present. The PI is Dr. Boyin Huang. He is there right now in your room, and you can talk to him. And of course, this is intended to be the long-term, very long-term centennial scale climate monitoring. That's based on in situ data. There's a new version. Boyin has a paper submitted. It's under review right now. Basically use AI machine learning to improve the spatial variability and capture the more local scale variabilities. You can talk to him about this one. And then when we merge with the land, ocean and land component, we have the NOAA Global 10. Again, one advancement in this one is the AI machine learning to achieve early stability of the global system. Shown is one of the example of Antarctica region that runs on day 4. I'm sorry, let me go back. Hopefully, how can we go back? Yeah. Shown on there is day 4, day 8, day 16, and that's where the top one shows the collection of in situ data. Day 4 very sparse data, and day 6 a little bit more, and day 16 you have more data in that region. And using the formal EOT method, you see in the day 4 in this region you don't capture the code anomaly here when the real data coming in. But use the AI machine learning, you can catch this feature, the code feature, much earlier. So this is just one of the example, and so we use this method applied to the lender component and released in February 2024. You can see the two versions. Eventually they merge better, but there's a great divergence at the beginning. Again, Boyin is leading this effort. You can talk to him over there. Then the other one is OISSD, as mentioned by Sheekela others as well. And basically, we work with NOAA and also other international partners to collect the data, globally, including both in situ data and the satellite data. And then we combine them together and so use the in situ data, collect the satellite bias, and then make a climate consistent data. It has been used for mostly for marine wave monitoring and things like that. Some recent progress on OISSD, and why is the record setting SSD since March 2023 to present, and still really setting the record. There is the proposal presented by Boyin over there, and to diagnose the mechanisms, and which decompose into 3 components and the long-term trends, and so and decadal variability as well. And you can learn from him over there. The other one is the experimental use of deep learning for bias corrections and use Amazon server for monitoring. This is going to be presented by Gary, and on Thursday you can talk to him in detail on this one. Under the sea surface temperature, we also produce the sea surface. The most recent version is the version 2. We basically blending multiple satellite observations, and the most recent version can resolve the hurricane scale winds as shown on the lower left corner, lower right corner here. The data sets is from 1987 onward, and global quarter degree and the 6 hourly, as well as the resolution. We did early evaluate the accuracy of the NBS, and so IP track has been considered as the truth, and for this case, and the yellow one is our products here, and the green one is the European Copernicus project one. The red one, the flat one is the ERA5. So in the storm case, our brand sequence result storm ones much better. And also we apply these sequence for the offshore applications, offshore farms. We build the capacity to build the wind roses, and also our team developed an extrapolation algorithms using machine learning. We shown on the left side. The red one is really and also the cyan one is the traditional empirical methods, and the blue one is the actual radar observations, and the green one is the use AI machine learning methodology, and has tremendous improvements on that as well. Yeah, these slides are presented by Sheekela already. I'm not go over that. On the cloud migration, I think that's efforts led by Ken Casey. He's there. On the schedule, you can talk to him about the potential schedule, and he's in charge of pretty much of the cloud migration. Yeah, this one talked about Sheekela already. I put future plans, several bullets there. OIST, we are trying to have a new version release with be consistent with the input data. Right now, it's a mixed bag. It's AVHR for part of the time, early time period. The later time is multi-satellites, and we're trying to get the multi-satellites use Oxbow data for the whole time period, 1980 to present. Last year, we get a little bit of funding for experiment AI machine learning to improve products, and that's including ERSSD paper has been submitted. OISD just getting started, and Gary will be presenting on his experiments. And again, this is a very small amount of money, and beyond that, quick investment. We don't know whether get additional funding continually or not, but we will see. And of course, because this is a high-level product, we continue to improve the monitoring system, make sure we understand what's going on. And no data is perfect, for sure, but at least we understand what's going on, and when they are quoted by the media, and so on and so forth. That's all for my presentation. Again, Boyin and Gary, probably you can stand up over there. People can identify you, and they can talk to you about many things you are doing over there. Okay, thank you.
Thank you. Any questions? Okay. Okay, I don't see any questions, so thanks again. And we move on to the next presentation, which is Andrea Pisano from CNR, giving us an update on Copernicus Marine Service sea surface temperature.
Good morning, everyone. I'm Andrea Pisano from the Italian National Research Council, CNR. Okay, thanks. Okay, I'm going to present you the Copernicus Marine Service and the SST TAC, which is the element in charge of the provision of operational SST data within the Copernicus service, and the status of the SST evolutions plan for this year. So the Copernicus Marine Service is the marine component of the European Space Program for the Earth monitoring. And it provides regular and accurate information of the oceans, and the number of users increases year after year. The mission of this service is the monitoring and forecasting of the global oceans and the European regional seas, such as the Arctic, Baltic Sea, Mediterranean Sea, Black Sea, and part of the northeastern Atlantic Ocean. So observations mainly collected from satellites and in situ, as well as numerical models, are used, elaborated every day to provide a huge variety of essential ocean variables covering the blue, white, and green ocean. All these data are provided or better cover are provided as multi-year data covering from 10 to 45 years, but also as real-time data representing the current day or the previous day, and forecast from 2 days ahead. The offer of the whole Copernicus Marine Service is really wide, from the physics, such as temperature, salinity, currents, waves, and so on, to the biogeochemistry, nekton, plankton, chlorophyll, oxygen, nutrients, and so on. There is an extensive use of Sentinel data from Sentinel-1 to Sentinel-6. Each product is typically accompanied by a product user manual and a quality information document, and there is a service desk 24/7. This is a snapshot of the catalog. So finding the desired product is fairly easy, even if the large amount of product, almost 300, can cause some trouble among the users. This is one of the feedback we often receive. And this is a snapshot of the visualization tool provided within Copernicus, which is as this year updated, and I have plotted 3 layers of data. In the background, there is a daily map of gap-free SST. Let me see if I remember well from Ostia. Above it, seawater temperatures collected by all the available in situ platforms and shown as dots, and above all, a level 3S map of the sea surface height. Well, this is just an example of the visualization tool. This slide serves to introduce the SST TAC. So basically, how it works, the Copernicus Marine Service, there are, there are 7 MFCs, monitoring forecasting centers, in charge of the provision of model data, so 3D, 4D products, and a thematic assembly center, among them the SST TAC, for the provision of 2D surface data, since based on observations only. All these products are sent to a marine data store, which is in turn accessible by the users. So moving to the SST TAC, well, the mission of this TAC is the provision of accurate operational level 3S and level 4 SST products. These are primarily based on satellite observations. These are also provided in near real time, as near real time and multi-year or reprocessed data. So basically, we start from level 2. Our upstream data are the level 2 data collected, for example, from European agencies like EUMETSAT and ESA, and produce merged multi-sensor and level 4 data, which are successfully used for data simulation and scientific and climate application. We also internally use this data to contribute to the Ocean State Report, which is a yearly based peer review publication. The SST TAC is a science and user-driven service. This means that the evolutions of the SST portfolio follows answers to users' needs and requests. But we also try to improve the accuracy and quality of this data. The offer of this service, as I said before, is consists of global and regional SST data. They are provided in near real time, covering the last no, I did some mistake because this is not my presentation. Back. Okay. Okay, maybe I can. Okay. So near real time, covering the last 2 years up to 1 day before the real time, and multi-year covering the satellite era, so from about 1982 up to 1 month before real time. Typically, these data are provided as a daily mean map of the foundation SST, but there are also hourly mean products at the moment for the regional seas covering the Mediterranean Sea, Black Sea, Baltic Sea. Also, we strictly follow the GDS specification. So all these data are GRIS compliant, and most of them mirror to the GRIS into the GRIS catalog. Okay. This is an overview of the evolution plan for this year. Usually, the Copernicus Marine Service provides an evolution of the catalog once a year at the end of the year in November. And so for this November entry into service, we plan an improvement of the effective resolution as well as an improvement of the accuracy of the SST gradients for the Mediterranean product. There is a poster by Claudia Fanelli and a paper which is currently under revision. Well, basically, this improvement is based on the application of convolutional neural networks, and it seems to work well. Red boxes indicate an improvement with respect to the present version. We also plan an improvement for the Baltic Sea products with the release of a new land mask and an improvement of the sea ice estimation. We have here Joanna Caragalli, who is the responsible of the Baltic Sea products. We also plan to release a new global reprocessed SST product called Odyssey. This is under the responsibility of IFREMER. So we have here Jean-François Piolet and Emmanuel Autré. So at about this product has an effective resolution, nominal resolution of about 10 kilometers, and will cover the period 1982 to present. And we also plan a full reprocessing of our multi-year products, so both global and regional, by using the latest version of ESA CCI, the version 3.0, which has been recently publicly released. So that's all as a summary. The SST TAC is a service under continuous evolution. It is highly dependent on satellites. At the moment, we are using about 13 satellites for the near real-time production, but also in situ data, mainly for validation purposes. So it is essential regular interaction with ESA and EUMETSAT, and not only. We also give support to the European Commission for the mission design of the new generation Sentinels, And as a future plan, we are looking towards for coastal application, taking advantage of future missions as LSTM, Trishna, and SIMR. So thanks from my side.
Thank you, Andrea. Any questions? You need to come to a microphone. I think there's.
Yeah, the improved sea ice mask you mentioned for the Baltic, is that just for the Baltic, or is there an improved sea ice mask generally available? Just the Baltic. Okay. Not that I'm not interested in the Baltic, but okay. Okay, right. Right. Thanks.
Okay, thanks. So we move on. Okay, so for the next presentation, I'll give the EUMETSAT update. Okay, so I'll give the EUMETSAT update now on behalf of myself, Gary, Igor, and Estelle. Okay, so we have a range of different products for sea surface temperature and sea ice surface temperature. Stephane's already described the activities of the Aussie SAF. So this really encompasses both the Aussie SAF products and also those produced under Copernicus funding from the Sentinel-3 satellites. So the two links there are really to find more information are the link there from the Aussie SAF and also for slstr.eumetsat.int. So we have a range of different products. The Sentinel-3 SST products are giving us the reference quality sea surface temperatures, but with a slightly decreased swath width. And then these are complemented by kind of larger coverage from the AVHRRs produced by the Aussie SAF and good stability from the Aussie SST products as well. So there's a range of different products, and we're also working towards future EUMETSAT microwave global SST from SIMR in the kind of 2029 timeframe together with ESA. So this table just gives a kind of a good range of all the different missions. You can see there are many. The existing operational ones there are there in green. So these are either a combination of the produced by the Aussie SAF or produced by EUMETSAT under Copernicus programs, or they're kind of shared EUMETSAT and Aussie SAF activities. The blue ones there are the ones that are currently implementation, and the orange ones there are the ones that are coming up. So there's quite a range for both sea surface temperature and sea ice surface temperature. For the Sentinel-3C launch, internally we're currently working to the assumption of a launch date in July 25, but realistically this will be probably 2026. So SLSDR from Sentinel-3 provides us our reference sea surface temperature. These are very high quality dual view sea surface temperatures. And we're also working towards sea ice surface temperature products from these as well. So the status of our current SST products, these are the from SLSDR, these are the ones that are operational. It's been a fairly stable collection 3 for the last few years. There were some updates in 2022. There are some large evolutions ongoing at the moment. Gary has got a presentation on Wednesday, I think, to give a full detail of the day 2 SSTs and day 1 ISTs. So the main key points there really are that these will now produce SST depth and an SST skin within the products, and there are new IST products for sea ice. But yeah, please take a look at the presentation from Gary for all of the details on that. So we also do lots of validation and match-up data sets for sea surface temperature. And there's a presentation on match-up database standards by Igor and Jeff later on today in the task team presentations. But we're really aiming to continuously improve and evolve SST and IST operational performance monitoring. So this means doing the METIS into comparisons and producing MDBs for a whole range of different sensors, all the Copernicus ones and also the AUSISAF ones, and also putting that framework in place for the future missions. So yeah, please take a look at the presentation by Igor and Jeff, and I'll also give an update on fiducial reference measurements on Wednesday for both SST and sea ice. Harmonisation of SST and IST. So as you've seen, we have a wide range of different missions and products from both EUMETSAT Copernicus activities and the AUSISAF and the activities we work on together. So this means that we're really working much more on harmonisation of all of these different SST products, the definitions and the methods. This is one of the reasons we're starting to produce the SSTR products with an SST depth as well as an SST skin, and the AUSISAF are looking to do similar. So we're also working towards consistency of these products at high latitudes for SST, the marginal ice zone and surface temperature products, and also working on harmonisation of the performance monitoring, validation and assessment tools. So there are lots of benefits of this for users. It's an ongoing process. We're working on it already, but it will take a few more years. It will improve the SST data quality for users. It provides improved and consistent error characterization. It offers resilience to gaps in the constellation, and it's quicker to introduce new sensors. And it maximizes the benefit of the reference SST, such as from SLSTR. It also maximizes the benefit of fiducial reference measurements, and it means that we can do collaboration in key developments, such as the diurnal variability model and retrieval algorithms. So we've been working quite closely with NOAA and also Meteo France on developing diurnal variability model for SST, and I think Gary's going to talk more about that in his presentation later in the week. In the longer term, this means we're also starting to think about other possibilities, such as new approaches to harmonise the EUMETSAT polar sensor and geo-SST constellations, perhaps through bias-aware optimal estimation, which we've seen from presentations from Chris and Owen before. So to summarise, we continue to provide excellent SST and IST reference and operational products through both the Copernicus activities and with the AUSISAF. Sentinel-3 SLSTR provides a reference sea surface temperature operational time series. We have a couple of large ongoing projects. The first one there is the Cypher Mass project. So within this, we manage our SST and IST algorithm developments. Also, we work on improvements to the CalVal framework, and this is also where the GRIS project office is run with the DMI. So in terms of the first two things, the algorithm developments and improvements to CalVal framework, then we have IFRIMA, Meteo France, University of Reading, Met Norway, and DMI involved in all of those activities. We also have a project to continue the fiducial reference measurements for SST and IST, the Trusted project. So I'll talk about that later in the week, and that's led by CLS with many other partners as well. We're also preparing for SIMA microwave SSTs, I also mentioned, and also working together with ESA on the next generation optical from Sentinel-3. And that's all. Thank you. Any questions?
Hi, Anne. There's a question online from John, and he's asking for the meaning of harmonization.
So this really means when we've got multiple missions and multiple satellites and sensors, that we have the same definition of those products, so that when you're using the data products together, say in an analysis or some other application, that you can use them in a consistent way. So that means consistent definitions of SST skin, SST depth. It means consistency within the uncertainties and the SSCS bias and standard deviation. But longer term, it also means consistency with the cloud masking, the retrieval algorithms, and in the end, then we'll have a much improved whole constellation of SST products. Okay, there are no more questions. John, there's one to the left of you.
I'm sure you're aware that there is work going on at EUMETSAT in collaboration with, for example, MPL, to start looking at the issue of potential level 1 biases and level 1 corrections and uncertainties. But what's not clear to me is if that kind of work, you're talking at EUMETSAT about moving that also into the operational sensors, because the projects I'm aware about are through the climate data side of things, so it's all the older ones. But personally, I know that level 1, I mean, you've talked about bias-aware optimal estimation. If you fix the level 1 to improve it, you'd reduce the need for bias-aware optimal estimation. So is there anything in the air about doing something with the level 1?
Not immediately, but I think that's the kind of the ultimate aim, is to feed in, developments, improvements in the climate data records, then to sort of offline NTC, non-time critical processing, and then eventually to the operations. So that would be kind of like a sort of a circle of improvement that we would like to see, but obviously it will take some years.
I'm just making sure that it's in your plan.
We're thinking about it.
Okay,
yeah.
Thank you.
Okay, so thank you. So the next presentation now before coffee break is the NOAA STAR presentation by Olafur Jonasson.
Hello, can you hear me? Okay, can you hear me? Can I test?
Yes, we can hear you.
Okay,
Yes.
let's have compliment. Thank you. So my name is Olafur Jonasson. I'm going to talk about the status of NOAA Expo SST product. So this is my team, and unfortunately I was not able to be there in person, but Veronica Lenz is there, and Irina is there in the room also. So you can talk to them if you have questions after the talk. So first I'm going to talk about updates on NOAA 21. So it was launched in late 2022 and renamed NOAA 21 after the launch. So it's in the same PM orbit as at 1:30 a.m. PM as NPP and NOAA 20. And it became the primary afternoon satellite on March of this year. So, but ST is still available from the secondary, which is NOAA 20, and tertiary, which is NPP. So there was a NOAA 20 rephasing performed between March and April. So that's when the NOAA 20 satellite was moved to be 180 degrees or half an orbit ahead or behind NOAA 21. And this figure here on the right shows the current GPS constellation. So you see NPP is right in the middle, and NOAA 21 and 20 are half an orbit apart. So NOAA 21 SST was declared fully validated in February of this year. And it's available back to March 19th of last year. So it's on NOAA Coastwatch, PODAC, NCEI, and also operational NOAA 21 SST is now available from NOAA OSPO on PDA. So as Sheekela talked about that in an earlier presentation. So we also have updates on the global 0.02 degree LTS LEO SSTs. So we have 3 lines. So it's the PM from afternoon satellites, so 2 files per day, day and night, and included. So recent updates were to include MODIS, Aqua, And we also have 3 virus sensors currently available, so MP, NOAA20, and 21. So we have complete archive back to 2002. So that's when Aqua ST was first available. They're on PODAC and Coastwatch, and operational production at NOAA OSPO is currently underway, so it will be available next few months. And we also have the AM product, so that's from the mid-morning AM satellites. So it's the same 2 files per day, and that includes EUMETSAT, so MATOP A, B, and C, currently only B and C. So we have complete archive of this available back to 2006 on PODAC and Coastwatch, and as with the PM product, it's currently being introduced into operations at OSPO. And lastly, we have the daily product. So this combines the PM/AM and day-night and Terra STs into 1 file per day. So it's normalized to 1:30 local time. And we also have complete archive of this available back to 2000 on PODAC and Coastwatch. So the table on the right shows you an overview of what satellites are included in what product. So PM/AM daily, and also the start and finish of each satellite. So we included the MODISes, but they are currently not ingested into L3S as of 2022 because of drift in orbit. And the time series on the bottom right here shows the clear sky ratios, this number of ocean pixels with SSTs as a function of time. So you can see as we introduce more sensors into each line, we get more of a clear sky, better improved clear sky ratio. So it all starts here with Terra, with the daily products, and PM starts in 2002 and AM in 2006. And you can see in the recent, since 2018, we have had about 65% clear sky ratio in this product. So this slide here shows an example of our PM nighttime product. So this is PM nighttime imagery from 4 satellite overpasses. So you can see in the 4 corners are satellite overpasses from MP, NOAA20, and 21. So these are all combined into a single product. So the L3S PM with, they're combined in a way that doesn't introduce imagery artifacts, and it also maximally preserves the resolution, feature resolution. It's the same here with the daily product. So in the 4 corners, you have the PM night, AM night, PM day, and AM day. So these 4 are combined into the daily product, or DY. So this product, as mentioned before, has the maximal coverage, but it comes at the cost of lower temporal resolution, and it's normalized to 1:30, which is the PM nighttime local time. And so we can see here the black curves are thermal fronts overlay, so it's indication of the presence of a thermal front. So we also have in the files we also have the strength in Kelvin per kilometer also available. So we can see here in a poster called titled NOAA Expo version 2.8 thermal fronts product, if you have more interest in the thermal fronts products. So as for comparison of L4, so the 0.02 degree L3S LEO daily and the other PMA maximally preserve L3 USST features. So they typically have superior feature resolution than the highest resolution L4 products available. So you can see here the L3S LEO daily on the left and MUR level 4 on the right. So even though they have the grid resolution in L4 is higher, you can see that the feature resolution or features that are sold are actually finer in the L3S. So as for the GEO side of things, so NOAA provides satellite ST from geostationary satellites, so it's from the advanced baseline imager, so it's on GOES West, which is currently G18, and it goes east, which is currently G16. So this map here shows the coverage of each of these 2 GOES West and GOES East, and we also process the advanced Himawari imager, or AHI. So that's currently Himawari 9, but previously was Himawari 8, and that's operated by JAXA. So these SSTs are collated in time, reported hourly, so it's 24 files per day. And we earlier this year, performed a full measure reprocessing of G16, 18, Himawari 8, and Himawari 9. And you can see, and I follow the Coastwatch link here for always to access the data. So in this reanalysis, we identified long-term GEO SST drift in the GEO product. So on the left, both these time series show time series of bias versus VIIRS nighttime SST. So this is G16 on the left minus VIIRS and Himawari 8 minus VIIRS. So you can see a fairly consistent downward drift. So these are trends of fairly high, 0.27 Kelvin per decade for G16 and 0.17 for Himawari 8. And so all of our reprocessed G16 Himawari 8 data are detrended in the Expo version 2.9 data. So that's we use this trend line versus VIIRS nighttime SST to trend the historical data. So, but this, and we haven't done this so far for G18 and Himawari 9 because the visions are still too short to do that. And you can see for more information, you can see the poster by Victor. So it's the historical and real-time geostationary expert SST products from GOES and Himawari satellites. So I'm not going to go too much detail of this. This table, it just shows you all the nice places you can access our data and where you can actually get the, so this is near real-time data, and this is RAM sensory analysis. So if you want the detrended data, you have to go for the reanalysis data, and it has to be version 2.9. But you can go to, as I mentioned, CoastWatch to find links to all of this data. So again, if you want the detrended data, it's 2.9 RAN data reanalysis. So as for the in situ SST quality monitor, or IQUAM, so this is a system established in 2009 to support the accurate and consistent CALWAL of satellite and blended SST products. So what it does is collects in situ data from various sources, performs quality control, and distributes the data in monthly NetCDF files. And you can follow the link here for the IQUAM website. So we are now working on updates to which we will call version 2.2. So current version is 2.1. So we're adding 2 new data sources. So it's iCodes CMEMS for as an input data set. So what these two will do is the improve data completeness. So you can see the figure in the top right. So you can see the daily number of unique SST drifter observations for between April 1 and May 15th of last year. So you can see the nominal number of observation is higher in 2.2, but you can also see there are often been data gaps, which is due to data gaps in FinMock that we are now have been addressed. So these have been happening more frequently recently. So there's also been improvement to the QC algorithm. So you can see Yaping's talk in session 5. So this is on the lower right, you can see the telephone talk here. And this 2.2 data is currently available for evaluation. So this is still in testing, but you can take a look at the data if you are interested. So as for future plans for Oxbow LEO SST, so current version is 2.8 and 2.81. So now we're working towards 3.0. And our main focus in this current development is to improve the virus clear sky mask. So we're always trying to reduce residual cloud leakages, but the main improvement in this version will be reduce the overscreening of dynamic regions. So this figure on the right shows a sneak peek of beta 1, so the first beta version of our L3S data. So this is using the test version of this mask. So this is PM, so this is virus data. So you can see on the left, you can see the current version of L3S LEO PM, and you can see all these rectangles identifying regions which have been masked consistently between all of these overpasses during that day. And on the right, so we can see the new results using the new clear sky mask. So this release is planned for 2025. But this slide here shows the same thing, but same SST imagery, but we have subtracted the foundation SST, which is CMC level 4. So we can see, because of the lower resolutions, we can say why we are, it's very clear why these regions are being overscreened. So basically they are cold anomalies or warm anomalies. So we are heavily using comparison to level 4 in our cloud mask. We're trying to reduce this comparison or the weight of this test to reduce false detections like this. So as for a summary, so for the near-term priorities, so GOES-U or G19 is currently planned for launch in late June. And it's planned to replace G16 as GOES East in April of next year. So this will be the last satellite in the GOES R series. And as I mentioned, they were working on Oxbow 3.0 with updates to the clear sky mask and IQUAM 2.2. So it's more source input sources and improve the QC or the CALWAL. The planned release is late 2024 for new version of IQUAM, but you can already look at preliminary data. So thanks for listening. That's it. So if anyone has any questions.
Thank you. Any questions?
Thanks, Holly, for nice presentation. There are plenty of different versions of the products. I'm wondering with NOAA 21, so you mentioned it is available through PDA. So which version is that available operationally?
Yes.
And will the new version 3.0 will be available with NOAA 21 in 25?
Yeah, all three. All three is the releases for all three versions. So it's MPP, Note 20, and Note 21.
Thanks.
Okay, any more questions? There's a comment online if you want to check, but I don't think it's a question. Okay, so if there's no more questions, then I think we break now for coffee, and we resume in half an hour, or quarter past 11.
Yeah.